Start. Hello. So the idea today was to show you what we are doing in Semtech R&D team, and to expose you a bit the process of what is behind the LoRaWAN. So I'm the director of the R&D team in the LoRa system team. I'm based in France, and we are working on LoRa systems since now more than 10 years. So here I'm trying to expose what is behind the stack that we provide and the reference implementation of Semtech. So there are three key principles that I think are important to us in our development process. The first one, of course, is that we wanted this multi-dimensional structure of the stack. What I mean with that is basically that we have, of course, all the LoRaWAN features, and we go through all the radios and different validation through that. Also, it's not just software. It's not just about software. The team that we have is very skilled on radio performance, and for us, this is what we have in our DNA. I'm an RF engineer as well, and the radio performance is what is behind everything we are doing. And the third point is that we did everything so far for the LoRaWAN stack, but now we start to open that model to other implementation and other usage of the software that also Shar here will present later. Okay. So, of course, already powers million of devices, and we see a lot of traction also from the stack, so it's getting more and more the reference implementation for the LoRaWAN as well, okay? So there are two kind of type of LoRaWAN modems, okay? There is one that is completely open source, running on our transceiver, and is running on external, of course, memory with external flash and etc. And then there is the other model that is more the embedded version of the stack, so the complexity is within our chip, okay? And people get exposed to the API for that reason, okay? So those are the two flavor of our software, okay? You can find more information on our website, but this is the basics. So if I enter a step deeper into what is this multidimensional support that I'm speaking about, there is for sure the entire feature set of the LoRaWAN. So we are the reference implementation. We are fully certified. Everything that is in the LoRaWAN is supported by our stack. So we have all the classes, all the regions, and of course there are relay, fault, and multicast that are the feature that the LoRaWAN, as you know, expose. Also, another important point is that we cope with all the Semtech radios. Okay, we have generation 1, 2, 3, 4 is coming up. So this is what we have. LoRa Plus that Shar will expose later is the newest version that will be supported. And the other dimension is whatever is your development platform on the MCU, meaning MCU, OS, development environment, Zephyr or not, we try to enter into that part. So lately we enter into the Zephyr development environment. We have implementation of that is publicly available. So we are also embracing that ecosystem as well. So those are the dimensions that, of course, we have not only to develop, but also to validate against. So you see that here you have a lot of dimension that has to be released, that has to be tested and validated at every release. So we speak here about more than 10,000 tests run per release. That is pretty big effort behind. So it's not done just for nothing. We try to expose you guys to the minimum risk when you take this stack. Of course, there are things that may be escaping the test, but there are a lot that is done. It's not just the feature, it's also the radio and also the different porting. Okay, so this is an important concept. Yeah, another point that is very key and important for us, the difference between other development team that I've seen around so far. What we try to build is a team that is radio aware. So at every step of our development process, we have radio performance in mind. So what I mean with that is not just sensitivity, that is where LoRa makes the difference, but it's also about TX power accuracy, is purest emission. So what you see there are the masks that are tested. So here you have, for example, ETSI regulation. So we do pre-scanning ETSI regulation. We verify that output power is correct at every step. We verify that the spurious emission is compliant with the different regulation. And again, we have ETSI, FCC, ERIB that are the main regulator environment that are out there, Europe, US, Japan, that are the most strict in terms of regulation, and we try to cope with that. Of course, we test sensitivity, and we test sensitivity over different impairments. What is a radio impairment? Is like frequency offset or blockers immunity. So those are things that we test over the stack. Doesn't mean that we test in continuous mode, in ideal mode, but we also test on protocol. We test the sensitivity when the packet should arrive. So basically, we test the timing, the RX windows are open the right timing. So all that is something that we test. So this is why we do a big heavy lifting. It's not just a stack, it's something that is tested against that. And more importantly, I don't know if it is more important or less, but every millisecond counts. Okay, what does this mean? Is that we try to maximize everything that is the timing, of course, for the MCU, but also the radio. So we don't switch off on the radio when it's too early, and we try to switch off the radio soon enough when the packet is over. Okay, we reduce the timeout for that part. So here, we see what this is the current consumption of our LoRaWAN uplink plus downlink, and all those timing are checked. So the current consumption of emission, reception, and also the sleep mode. Okay, so this is very important, and is at the center of whatever we are doing. There are also calibration that are happening into the stack to calibrate and optimize the current against the crystal variation, right? Crystal may move over time, and then we try to calibrate that and track that part over time, okay? So that to reduce the amount of energy spent per packet received, okay? So this is another concept that is pretty important for us to follow, okay? So now if I go to what next, okay? So we understood the amount of effort that is done for the LoRaWAN stack. So now what next? So we try to apply similar concept to a larger exposure of our radio to other protocols, okay? So we know that Semtech radio are not just doing LoRa, they are doing other modulation, demodulation and stuff. So we would like to apply the same concept to coexistence of the LoRa with other technology or other protocol on top of that. So here is what we are working on, and you can see that at our booth, and also we're gonna discuss this about a bit later. We see that we can here make coexisting multiple protocols. So what we mean for that? Here you see basically a kind of very long series of emission. This, by the way, is a ranging protocol, meaning that our radio can make ranging measurements, okay? So basically with a lot of exchanges between TX and RX. So we have a long sequence of TX and RX, in this case TX, and in between there is a LoRaWAN packet, uplink and downlink, that is perfectly interleaved with that protocol. And that is happening very kind of in an optimized way through independent thread. So this idea of exposing the radio capabilities and make the coexistence simpler for the customer is what we try to show. We're gonna show you later what does it mean for us. Also, we are coming with an idea of a unified software platform that will expose all that. So not just LoRaWAN, but the same idea of very good performance in terms of radio, optimization of the timing, and the power-aware idea that we also get is something that we want to expose for every kind of protocol. Also here you see something similar. So the same thing, but how this is happening over time. So this is a spectrogram. You see a multi-hopping protocol that is very fast, and in between that you have the LoRaWAN packets that are in that case there, okay? So just another view of that. So that's everything I wanted to say for you today, okay? The idea is very much to show you what is the effort behind the LBM and how we want to open that for the future evolution of our radio, okay? So now Shar will show you what does it mean